Thank you. Good morning, everyone. I'm very happy to be here to present the first workshop of this conference that we're going to call How to Unlock the Full Potential of the PolyWorks Universal Cube Platform. Now, in your company, you may have access to several different 3D measurement devices. Whether we're talking about portable arms, CNC CMMs, single-point probing, or high-density point cloud scanning, having access to a wide variety of 3D measurement devices is a good thing, because you can always choose the most appropriate device for the piece inspection requirement and challenges you're facing. Now, for example, a CNC CMM is great to automate repetitive inspection. Laser trackers are ideal to measure over large volumes. Portable arms are known for their versatility and ease of use. But this is all great, but when you think about it, in many organizations today, all these devices use their own metrology software. Now, this creates a ton of problems. Throughout, for example, if you have a CNC CMM that is currently used to inspect a part and it's busy doing something, you can't take this project and bring it on an alternate device if you need to inspect more of those pieces. Or if you do, will you have to build a brand new inspection project to do so? If you succeed at making this project on the second device, are you sure you're still applying company standards that were maybe developed for the original software you were making the inspection in? Or, in the end, when you succeed and you have your measurement results in the second software, can you bring those results easily into the original software so that you can compare all the pieces together? And finally, obviously, you're probably thinking about this one. Maybe you're capable of doing that, but is anybody else in the company capable of operating the two software? So all these problems can only be solved by a universal software platform like PolyWorks. And throughout this workshop, I will demonstrate and explain why a single seat of PolyWorks and a single PolyWorks inspector project are sufficient to solve all the problems we presented. So here's our outline. I'm first going to start by talking about the Universal Digitizing Hub. And this is the fact, of course, that you can use several different measurement devices, either for the same inspection or for different piece inspections. Then, we're going to discuss about the universal workflow, or simply the fact that you will always use the software the same way, regardless of the device you're going to be planning your inspection with. And finally, we're going to see that the universal project allows you to inspect any piece with any hardware, and anybody can actually do it. So we will see that. So before I get started with the first poll question, just want to walk you through. In your app, you will see if you access the schedule, you will be able to select today's workshop, Unlock the Full Potential of PolyWorks Universal Cube Platform. And this is where every time I'm going to bring the slide that talks about a poll question, you can submit your answer. Now, you don't have to answer all the questions right away, but we'll start with our first question. So, just out of curiosity, on average, how many types of metrology devices do you have access to in your group? Is it only one? Is it two? Or three or more? And right now, I just want to draw your attention on the different types of measurement device I have in mind. Let's say we're talking portable arms, laser tracker, optical trackers, CNC CMMs, even manual gauges, calipers, micrometers, any of these tools, and any other you can think of. So I'll give you a couple of seconds to answer that. And let's take a look at the results as they are coming in. So I'm very glad to see here that many people have access to more than one measurement device. Now, for those of you who only currently use one measurement device, maybe you don't see the need to have a universal platform, but I'm hoping that this will actually raise questions that you might consider in the future. And for those of you who are already using several devices, I'm hoping that this workshop will open your eyes to new capabilities and give you valuable tips and tricks that you can use. So let's get started with our first project. So this is a project that we built using a CNC CMM, using probing only. Now this is a sheet metal part, and probably you have seen PolyWorks being used with different measurement device, either in your company or here in the network pavilion. But did you ever realize that one of the greatest assets of PolyWorks is the fact that you can use the most appropriate measurement device to conduct a specific measurement inside a piece inspection? In addition, if you mix different devices together, you can get a single inspection report to get all those measurements together. Now, this is what I will demonstrate with this project. First of all, as you can see, we built our inspection on a CNC CMM, and we started with a CMM pre-alignment, and we followed it by a best fit measurement object that uses a 4-way hole, a 2-way hole, and simply 3 surface comparison points. Now, in addition to that, once the alignment was obtained, we actually decided we would measure everything we could reach from the top orientation of our tool. Then, once this was completed, we simply changed our tool orientation to be able to reach everything that we can measure from the side. Now, this is where the quality manager comes at me and tells me, fine, okay, we have inspected those pieces, we have our inspection reports, including control views, and now he asks me, from now on, we'd like to make sure we measure the thickness of all those sheet metal components in this assembly. Now, the problem with that, I could find a fancy way of doing this with the CNC CMM, but you probably know that this might not be the most efficient way of making the measurement. In other words, maybe a good old micrometer would do the job to measure those thicknesses. So this is why we came up with the new custom measurement tool that allows you to create a measurement object that we call a custom measurement, and you can actually locate it exactly where you want the operator to perform the measurement. Now, what's great about it is the fact that this acts just like any other measurement object. So you have this distinct branch in the tree view, and you can actually set the nominal value. So for example, if the first component has a 1 millimeter thickness, I can set those values directly in the geometry control pane. Now, I can do the same for the second thickness that we've defined, and this time I'm going to go with a 2 millimeter thickness and maybe plus or minus 1. Now, from this, when it's time to perform the measurements, I can simply right-click and go Define Measured. Now, in order to do that, I would take my micrometer, I would take the measurement, and I would come back to the computer and just type in the value that I want. I also have an additional field where I can write notes. For example, for traceability, I could go with the serial number of my micrometer. And there you go. Once this is done, you can see, just like any other measurement object, that you have your pass or fail status being displayed in the 3D scene along with the measurements. Now, I can do the same thing on the second one, following the exact same procedure. So I would take the measurements. Again, I can choose to add my serial number. And once this is over, this is also a measurement that I can include in any control view. So if I want to create control views that only include the measurements from my custom measurement objects, I can. And for example, I would call this one thickness. And it's part of my report now. Now, let's take a look at the measurement sequence that we have in that project. Now, this might be a little bit intimidating, but let me reassure you, this is just the regular sequence for a CNC CMM, where we went through our pre-alignment, followed by measuring everything we needed for the best fit measurement object that is performed here. And then we simply measured everything we could reach from the first orientation. Then we performed a tool orientation change and measured everything else. Now, the next time we're going to inspect this piece, I would like to make sure the operator remembers to perform those custom measurements for the thickness. So just like any other object, you can actually bring it in the sequence, and those two steps can be used, and you can actually simply say I want to provide guiding instructions such as use micrometer to measure thickness. And I can also add guiding images. So that way my operator will remember he needs to do that. Now let's take a look at what it will look like when it's time to actually perform those measurements. So we can see here our operator performs the sequence by first bringing the CMM in the middle of our first circle to perform the CMM pre-alignment. Now, once the point is acquired, this is where the sequence will start measuring using the CNC probe method. And we start by measuring the first constraining plane for our four-way circle, followed by all the points inside. Once this is completed, we will measure our surface points. And just because I'm sure you all get the point, I'm going to skip all the other alignment objects. And once the alignment is computed, then we measure everything we can measure from the top orientation. So that includes the two circles that are here, in addition to all the trimmed edge comparison points that we have to measure from the top orientation. Once this is over, this is where the CMM goes to a safe location, performs the tool orientation change, and we proceed with the remaining trimmed edge comparison points that we need to measure. Once this boundary will be completely inspected, we will then finish by measuring our two circles. Now, the sequence is almost complete, as you can see here, and as the CMM will move up to a safe location, this is where we're going to reach the step where we added our custom measurement objects. So this is what happens. As you can see, the guiding image pops, and we have our guiding instructions that tells us to use the micrometer to perform the measurement. So this is where the operator, of course, takes the equipment, makes the measurement, and simply has to walk back to the computer to type in the value. So as you can see here, the same interface we were looking at seconds ago when I was triggering the measurement myself is shown here in the sequence. And now we would do the same for the second thickness. So once this is over, you can see here that we have, if I open the project after we've performed the measurement, we have a project that contains our results, and again, I like to say that a lot, just like any other measurement object, the custom measurements will show some interesting trend charts where you can conduct SPC analysis. So we can see here our two pieces with the value. Now, in addition to those custom measurements where we measure the thickness, we can also perform visual inspection, as Martin introduced this morning. Like on this sheet metal assembly, there are some threaded inserts that needs to be welded to the sheet metal components. Now, this could be a visual inspection where we just want to check whether or not these have been installed properly. So we can create a different type of custom measurement object, but this time we call them qualitative measurements. Instead of providing a value, like in this case I could call them weld nut, so I can anchor them nearby the hole where I need to put the insert. I'll do the same here. And for those, when it's time to measure them, you just have to go define measured. And this time, instead of specifying a numerical value, I just say pass, fail, or warning. So let's say if the first threaded insert is correctly installed, I could go pass. Whereas for the second one, let's say it has been welded and it's out of position because it's not perfectly centered, I could go with warning and say centering issue. And in that case, you can see the results that are there, and this, of course, would be added to your control views, especially if you make it fail, for example. So if I go fail here, and I have a control view that is already set where I only see the failing controls, well, in this case, you could see that the failing weld nut would appear there. Now, this is all great. I now have an inspection that contains a mix of CMM measurements and external measurements performed with a micrometer and visual inspection. And this is where, again, my quality manager comes at me, I'm all happy, and now he comes at me and says, hey, we have a problem with these parts. We need to make sure we investigate what's wrong in the area here, because currently what we're seeing is a lot of variability and we have interference downstream in the assembly. So we need to know at least what are the highest and lowest deviations in that area. So I'm looking at this, and again, I'm thinking, okay, the part's still on a CNC CMM table. I could inspect that using the probe, and I could probe several surface comparison points. First thing is that's going to be time consuming. Second thing is there might be some collision. Maybe the part is not located in an ideal manner to quickly measure those. And ultimately, we would all know that this sounds like a job for a laser scanner. Now, it's great if you have a laser scanner for your CNC CMM, but the model I'm using right now doesn't. So what do? Again, I have solutions. The solution is, I know I have a portable arm with a laser scanner that's nearby. So why not bring the portable arm and perform scanning on that? So how can you do this? Well, the first thing you're going to have to do is simply make sure you can register everything you have already measured with what you're about to measure with the portable arm. In this case, I've already measured some circles with the CNC CMM. So let me just select these and create some device position targets from those circles. Now, those were actually measured with the CNC CMM, and this is where I would be ready to say, okay, let's bring in our portable arm, and in this case, I will simply perform a device position move. So now, position 2 will require me to define targets. Now, let's take a look at what this gives us. So the part is still on a CMM table, and I'm bringing my arm that's on a tripod. Now, at this point, the only thing I need to do is hook up the arm to the computer and connect to it. So this is what's going to happen right now. From there, I will simply have to define targets from the same circles that were already measured with the CNC CMM, which is what I'm going to do right now. So we can see here the first target being defined by probing the constraining plane of that circle, along with all the holes inside, all the points inside the hole, followed by our second target, and finally our third one. Now, once this is completed, we will be able to look at the device position target match, and once the match is obtained, we know our arm is now registered to what was already measured with the CNC CMM, which means that I can now start scanning to get the data to perform, let's say, the color map that would reveal the high and low deviation in a specific area. So here we'll only see a couple of scan passes being done. And now if I take the project in which the scans were made, this is what it will look like. So you can see here there's a little bit more that has been scanned than what you saw in the video. But in the end, the only thing you have to do is make sure you select the area of interest on the CAD model, which is what I'm going to do right now. And I can simply perform my color map. And once this is obtained, I can go here, just make sure I display the min and max. And if I'm happy with this, I can take a snapshot. And I just want to draw your attention on the fact that my formatted report now contains results that were measured with my CNC CMM, results that were measured with my micrometer, and scan data that came from a portable arm. So that proves that in such situations, having a universal digitizing hub is an important asset when you're making inspections. So I just demonstrated the advantages of being able to work with different devices in the same project. But one thing for sure is you don't want to have to change the way you make projects depending on which device you're planning on using. So this is why you need a software that has a universal workflow. And this is the second dimension of universality. So whether you are planning to perform an inspection on a part using a portable arm or a CNC CMM, you're going to notice you will go through the exact same steps in PolyWorks. Now, let me just make a demonstration of that. I will use 3 different examples in which I will build a project, and then if you realize you need to use that project on another device, I'll show you that you can very quickly adjust the project to be able to be using it with a different device. So I'll go through 3 examples while doing that. Let's start with this first one where we have a casted manifold. And in this particular part, we have defined some datum features, namely datum A, which is the top plane, datum circle B, and datum circle C. Then we wanted to perform an inspection on the front flange here, so we created a plane on which we will perform a surface profile and a pattern that we'll use to measure the position of all the holes in that bolt pattern. In addition to that, because this is a casted part, I might be interested in measuring the fillet radii in several locations, so I created profile gauges. Now, after you've defined all your nominal measurement objects, or the nominal components of your measurement objects, this is where you would normally connect to your device and start performing the measurement, which will at the same time automatically record all the measurement methods inside each object. Now, when you have an arm around, this is very easy to do, but you might find it very convenient to use our offline simulation tool that allows you to simulate the connection to an actual device. So whenever you do that, this is where you're going to be able to say, let's connect to my portable arm, and at this point, the software acts just like if you were truly making measurements with your device. Now, if I'm thinking about this project and I look at my datum features, datum A, datum circle B, and C, you'll notice that because there are so many holes on this part, it is highly possible that when it's time to measure, I could choose the wrong hole if I'm not paying attention. Imagine if you're not the one who actually made that project. So in order to help the operator make sure he's on the right hole, I'm going to use a pre-alignment. So very commonly when we're using portable devices, we choose to go with a surface point alignment. So what I can do with this, of course, is simply define 6 measurement points. And here I'm going to try to go as fast as I can to define those. And the nice thing about the simulation mode is the fact that as soon as I'm done, I could press probe measured. I was already connected, so it measured them for me. But the offline simulation allows you, of course, to get instant measurements, and which means that now the alignment is available in my tree view. And from there, this is where I would start recording all the measurement methods in my objects. For example, when I go probe measured on datum plane A, this is where I could choose not only to go with the standard point acquisition method, but rather rely on the guided mode where I could force the operator to use 6 measurement points for that plane. And of course, in this case, I don't want him to be restrained to those 6 exact locations, but I want him to have 6 points. So I'm going to go with that. And as you can see, it is now measured. Now, the same thing would apply to datum circle B and C. So what I want to do in this case is just go probe measured, making sure that both circles are using the proper constraining plane. And of course, in this case, I'm going to go again with the guided point acquisition mode, and this time with only 3 points. So I'm going to go probe, and from there, I have all my measured components, which means that I can now perform the datum reference frame alignment for my GD&T analysis. Now at this point, I would like to make sure the remaining measurements are extracted from scan data. So the offline simulation mode also allows you to gather all the data you need by simulating data from the CAD model surface. So right now, this would be extremely useful if I had to do a best fit, if I had to do a color map ahead of time, or, like in my case, have the capability of extracting all my measurement objects on that data and making sure I can record all the measurement parameters necessary for the extraction. So it's about to be done. And once this is completed, this is where I will simply go extract on the remaining measurement object, namely all the flange features and the profile gauge that I want to measure this. Now in the end, this is where I would create all my control views for my reporting needs. So maybe I want to go quickly, I'll just create one for the front flange, and in this case, I just want to use our new tools for the annotation placements, where I can get something quickly done. And I'll call this control view flange and create the formatted report that goes with it. Now, if this is the project I needed to perform my inspection, let's take a view at what happens when I truly bring this part next to a device and I perform the measurement. So you can see here, the only thing I need to do is hit New Piece, and I will launch the New Piece inspection. And this is where it's going to ask me to measure our surface point alignment. Now, you'll see the purpose of that surface point alignment in a second, but as you can see, we're going to measure very quickly the 6 points that I defined. And from there, we will proceed by measuring our datum plane A with the 6 points we wanted to use for guidance. So the operator can try to hit approximately the points where they are shown on screen. Now, once this is over, you can see that you cannot make any mistakes while probing datum circle B and C, as you can see the orange probe that hovers around the right hole, which means that you're probing the right object. Now from there, we will start the laser scanner, and we will gather all the necessary data we need for our extraction. Just want to open a parentheses here that we have our feature extraction guidance that tells us with those orange pins if sufficient data was gathered to ensure a successful extraction. And once this is over, we can review the content of our project by taking a look at our control views, and we can see our results were properly obtained. Now, this, let's say, was a prototype part for which we started building that project in the first place. Now, after we're done with the scans, this is what I would have, and currently, the quality manager comes at me and says, okay, we're going to go full production with this part now. So we need to automate this inspection. In order to do that, there are several avenues that we can take. And this brings me to my next poll question. So if you want to take your app. So given that we have our project for a portable arm, which of these solutions would you choose to continue inspecting but with a CNC CMM? Would you A, build a new project from scratch? Would you B, modify the portable arm inspection sequence? Or would you C, record a new inspection sequence for the CNC CMM? Now, there are no right or wrong answers here. Just go with what you feel you'd be more comfortable with. Let's take a look at the results as they're coming in. So we have different numbers for all of these. Of course, I'm glad to see that very few people would choose to go build a new project from scratch. However, for those of you who have taken that one because you're most comfortable with it, it's okay. But I can tell you, after a couple of times, you're going to start realizing that no matter which project you're rebuilding, you're always going through the same steps over and over. So by yourself, you're going to realize that probably you'll be more efficient either with the second or the third option. Now, if you choose to record a new inspection sequence for the CNC CMM, it's all good. The thing is, did you know there's already a sequence in that project, even though I never recorded any? So we'll take a look at that. So option B, modify the portable arm inspection sequence, is what I will demonstrate. But like I said, you're just a small step away from doing that if you haven't seen it before. So let me just go back to my inspection project. And now, first thing I would like to do is go change my device, and this is where I would go with a CNC CMM scanner as well. And in this case, for the CNC CMM, I will choose a different configuration which corresponds to the bridge type CMM I plan on using. Then I can go new piece, but this time I'm not going to launch the inspection right away. And as you can see here, we have the auto-generated sequence that maybe you weren't aware if you're always using a portable arm. But in this project, even though it was made originally for a portable arm, the auto-generated sequence can be used to drive the sequence I'm going to build the CNC CMM sequence with. So this is the same sequence we were looking at, or that we executed seconds ago with the actual arm. Now, I want to draw your attention to the fact that you can always perform an adjustment to your measurement sequence based on the current device that is selected. Now, in this case, it's the CNC CMM. Now, upon doing that, you're going to notice that everything that was originally set to probe method is now set to CNC probe. Same thing for scanning. Everything that was set to scan is now set to CNC scan. These are the measurement methods that are stored inside the objects and that were changed automatically by adjusting the sequence. Now, as you can see, there are some warnings here, and this could be intimidating to some of you. Let me show you how easy it is to modify a sequence without making any mistakes. So first of all, PolyWorks will guide you, and before you perform any measurement with the CNC CMM, it's going to tell you you need a tool for that. Just go ahead and add the tool. It does it for you, and it chooses the tool you're currently connected to with the offline simulation. The same would work if you were connected to the actual CNC CMM. Now, again, it tells me that before I make the measurement, I need a tool orientation. So I will add the missing step, and it adds the tool orientation I'm already using on the CNC CMM. Finally, when I get to the first feature I want to measure, it tells me it needs CNC CMM parameters to determine the speed at which the CMM will move, the speed at which it will measure, and the approach distance that you need. So these are all the default parameters that you have control and that could be changed, let's say you need it. Now, this CMM would go ahead and perform the measurement of our datum features. And of course, I could show you by executing the steps one at a time using the offline simulation mode. You would see that our CNC CMM, after probing the surface point alignment using the jog box, then I would be able to CNC probe all the features that I need. Now, let me just accelerate the speed at which the simulation occurs. And we're going to see here that we're going to measure our B and C datums just before we perform our ABC alignment. Now, when it comes to scanning, you have two options here. Of course, you could take the jog box and drive the CMM manually and capture the scan data. You could do that. However, the intent here is to automate the whole inspection. So in this case, if I want to use CNC scan method, I need to define measurement paths. No problem. Let me just show you that you can build the sequence by recording those steps while in offline simulation. So this is what I'm going to do right now, simply by enabling the recording, and I'm just going to change my device or my tool for a laser scanner that's on the CMM, and I'm going to provide the tool orientation. Now let me just zoom in here and show you that in this case I would now be ready to define the paths. So I would connect to my CNC CMM and simply choose to define an area path. I'm going to go quickly here to do this area that covers what I need. Now, upon pressing Start Scan, you're going to see the CMM move, and you will capture data from the CAD model here because I'm using offline simulation. Now, at this point, I would probably want to change the orientation of my laser scanner, maybe to capture a little bit more data inside those holes, as all the circles on the flange will be extracted. So here I will just perform a go-to, so I can then use our pick tool orientation to change the orientation of the scanner. So I want something that's approximately 45 degrees from that edge. And then once this is done, I can simply create a second path simply by anchoring on the CAD, and there you go. I can resume scanning and capture the data I need. Now at this point, once this is over, you can see in the sequence all the steps for the CNC scanning were recorded, and now I can get rid of the step that was here, and the sequence would complete by extracting everything I need. Now let's take a look at what this would look like in reality. So this is the bridge type CNC CMM I'm planning on using. As you can see in the background, we have a tool changer where our laser scanner is already placed. So that means that when the sequence will reach the step where we perform the tool change, it will grab the scanner from the tool changer. Now, when it's time to start the sequence, the first step, just like when we were on our portable arm, will be to measure our surface point alignment. So you see point 1 and 2 here. We're going to skip 3 and 4 and just go directly to 5 and 6, which is on the left side. And once this is over, this is where the CMM will start going with the CNC probe method and drive itself to the proper location to perform the probing. So we can see our plane being probed again with the same 6 points that I used when I was using the portable arm. Once this is over, it will measure our datum circle B and our datum circle C with 3 points, as we did for the portable arm. So we really have the same inspection going on here. Then, once this is over, the CMM performs the tool change after we've done our ABC alignment, and this is where the laser scanner will start gathering data from the front flange. Now, I just want to draw your attention on something. When we built the sequence and recorded the tool orientations we needed, the software didn't know how the part was mounted on the CMM table. No problem. The sequence will stop and warn you that now that you've measured the surface point alignment, we know how this is oriented, and you just need to tell the software to compute the new tool orientation to match what was recorded with respect to the CAD model. So in this case, you can just resume, and from now on, every time you're going to run this piece inspection on that CMM, it's no longer going to stop. It knows the orientation it needs to use. It just needed a confirmation that this is truly what you wanted. And once this is over, you're going to see all the data being completed, and we can take a look at our control views in this piece number 2, and we see that we have everything we needed in the formatted report, and we have our second piece that has been inspected on the CNC CMM. Now, I just showed you we could change from a portable arm to a CNC CMM. I'm going to do the exact opposite now by going back to the original project I started with for the CNC CMM. Now, the only difference with the project I'm about to show you, we're using the exact same measurement objects, and we've defined all of our probing sequence, but on this part now, we are, sorry, I'm just going to disconnect, and I'm going to change the actual CNC CMM I'm going to be using for this. So in this case, it's going to be the Nikon CMM one more time, and I'm going to change the tool that we're going to be starting with for this. So now I have all the same measurement objects, and I've built the entire sequence just like we had initially when I started this workshop. The only addition that I've done is because I had a laser scanner on this actual CMM, I created the same way I showed you in the previous project. I created the scan paths that I need to perform the CMM scanning. Now, this is what would happen now if I was to press play inspection. Let's take a look at what we do. So this time, when we mount the part and we've built the project for the CNC CMM, we use the CMM pre-alignment with our first circle. So as soon as the part is mounted on the CMM table, the only thing the operator will have to do is drive the CMM with the jog box to the location of the first hole, and from there, the CNC CMM will start measuring automatically the required measurement object. In this case, the 4-way hole, the 2-way holes, and the 3 surface comparison points. So we can see our first hole being measured here with 4 points inside the hole. And then we continue with the surface point, one at the front. And once this is completed, this is where we would do the alignment and complete whatever we need to measure from this A0, B0 orientation, trimmed edge comparison points, the holes also that we have on top, and then we change the tool orientation and we complete the inspection of that boundary, plus we measure the 2 circles on the side. Now, after this is done, you're going to see the CMM go back to the tool changer, grab the scanner, and scan the entire surface of this part, because in this project, although I haven't shown it to you, we make a color map of the entire data that we captured with the laser scanner. So we have a hybrid project that's done on a CNC CMM. So while this is completing, let me explain what's going to happen now. Let's say in the company, we have this automated inspection. So we see the laser scanner now, and we're going to gather the scan passes. So in our company, this piece is now inspected systematically on our bridge type CNC CMM. And it's currently busy performing those inspections. The quality manager comes at me and tells me that suddenly we have a second sourcing for those assemblies, and they delivered a truckload of these parts. We need to inspect them right away. So, of course, we could think about buying a second CNC CMM, but that's not going to happen. So we need to inspect those parts right now with another device. So my 2 next examples will show you that we can convert the sequence to actually run this inspection on a portable arm or on another CNC CMM that would be a horizontal arm CNC CMM. So let's get started by taking a look at what happens if I want to use this project. So here I'm just going to take the project in which we have done the first measurements. So this is what has been completed while we were watching the video, where we have our scan data and we have everything in this project. If I look at the control views, so you can see here, for example, the top view that shows everything we need. Okay, so now I'd be ready to run this piece inspection on a portable arm to make sure we can inspect everything we need. So the first thing I need to do is go change the device I want to be using. So I'll go with a different portable arm, and I will launch a new piece inspection. Now, in this case, I'm not going to launch the sequence right away, as I need to make modifications to it. So maybe some of you could be intimidating by converting a CNC CMM sequence to an ARM sequence, but really, this is probably the easiest thing you can do. As you can see here, you already have warnings because depending on the device that you have, which is now a portable arm, these steps make no sense. There are no tool change or tool orientation change on a portable arm. So in this case, I will convert the sequence, and I want to draw your attention on the fact that what will happen is all the operations that were specific to CNC CMMs are now ignored, which is why they have this sign on them, and they're written in light gray. Now, another thing that happened here is everything that was set to be CNC probed in the measurement method of your objects is now probed. So the circles now need to be manually probed. All the go-to steps, just like the tool orientation change, were also ignored. And finally, if you had some scanning steps, the steps where the tool is changed and the steps where you were scanning with paths, which meant that was written CNC scan, is now just scan. So although this could work immediately as is, you're going to notice this warning here that tells you that because I used surface comparison points and circles when I started this best fit measurement object alignment, now that the CMM pre-alignment is gone, in order to be able to measure those features, I could choose to disable the guided mode by not restricting the points to be acquired to those points. Or you could also add a pre-alignment that is very common to any portable devices. So if you want, although it's not mandatory, you could decide to simply build a surface point pre-alignment, again, using the same approach that I used before with the offline simulation. So I can go with this, create the points, just make sure I put them on the side here. And because it's a pre-alignment, it doesn't matter if it's accurate or not, it's just to get me close. And in the end, you can just drag this in the sequence and all the warning will go away. Now from there, if you're ready to perform the inspection, this is how things would look like. So I bring the part next to my device and just launch a new piece inspection. So that will be the second piece I will be inspecting, and this time, while the CNC CMM is still inspecting some of those assemblies, I can continue inspecting other assemblies on this portable arm. So here we'll see our surface points being measured, and from there, the rest of the sequence will be applied immediately as we wanted it to be. So we're measuring our four-way circle using the same 4 points, and now we're measuring our surface points. Then I can go ahead and measure my two-way hole, and once this is completed, the alignment can be performed and we can continue measuring everything like the trimmed edge comparison points, the holes on the top, and then I will proceed with the remaining ones. Now, of course, all the tool orientation change steps do not exist anymore in this sequence, which is why things are pretty straightforward when you execute this on an arm. Once it's completed, this is where the sequence will prompt me for scanning the part. Now, in this case, it's just a matter of flipping the switch, starting to scan, and in this case, of course, no CNC scan paths are necessary, so they're simply ignored, and you can scan normally. And in the end, you will review the content of the project through the control views or through the formatted report. And again, we just went through the exact same steps, whether we build a project from an arm that ended up on a CNC CMM or from a CNC CMM that ended up on an arm. Now, let's say we still have more pieces to inspect, and instead of choosing an arm, we chose to use a second CNC CMM. So you could very well just choose, and I'm going to take the project that contains the results from my original CMM and the results for my portable arm, so you can see the two pieces. And now what I'm going to do is show you You can take the original project we built from the bridge type CNC CMM and use that on a horizontal arm CNC CMM, following, again, the same workflow, which is to simply choose the device. So in this case, it's still a CNC CMM. I just need to change the configuration. So in this case, I'm going to go with a different CNC CMM that happens to be a horizontal arm. And from there, I can go new piece. I'm not going to launch the sequence right away. And I'm going to make the modifications to the sequence live. So at this point, first thing is if I connect to this CNC CMM, you're going to see that right now the arm is not facing the part I want to inspect. So in this case, I need to correct the way the part is mounted on the CNC CMM table. So I'm going to do that by modifying my axis pre-alignment. Here it might be a bit confusing, but when it's your CMM, it's pretty clear. The goal is not to explain the principle here, but just to see the steps. And from there, you can see that there are errors on all the tools and tools orientation, and same thing for the laser scanner, because this is not what I have on that current CMM. Again, you can just go adjust to current device, and what's going to happen is you're going to need to provide these tools that were used in the current sequence and choose the replacement ones that are available on the CMM you're planning on using. Now you can see here the most obvious one being the change of laser scanner. So I'm going to go with this. The sequence is now ready, and I would just have to press play inspection and I would be good to go. And let's take a look at that final video where we can see the same part now being inspected on the horizontal arm CMM. And there are no tricks here. It's really the same sequence that you saw, I just modified. And this runs exactly like the previous one. So we do the CMM pre-alignment, followed by CNC probing our first circle. Once this is completed, it jumps to the surface points that are necessary for our best fit measurement object alignment. So that's our first point. Second point, and then we will measure the two-way hole that we need. Once this is completed, the alignment is performed, we can continue with the measurement. And you can see the adjustment of the sequence took care of making sure the proper tool orientation were applied for the horizontal arm CMM. And you can see it takes the right orientation to continue measuring everything that's on the side. Now I want to draw your attention on the fact that we have no tool changer on this CNC CMM. The laser scanner currently stands directly on the table, which means that in this case, since we haven't defined a tool changer, the sequence is simply going to stop and inform the operator he now needs to mount the laser scanner on the CNC CMM, and then he can just resume the sequence from where it stopped. We're going to see that in a second. So CMM moves to a safe location, and this is where the message stops you and warns you you need to mount the proper tool, which is the laser scanner. So the laser scanner is now on. We can just resume, and everything goes normally, and we have our CNC scans that are being captured. We can see the data being acquired in the background here. And once this is complete, no surprises, you can take a look at your control views and you will see all the results. So again, this is a proof that you can go through the same workflow regardless of the device you plan on using. Now, our universal project contains the results from several devices. Now, if I show you the project here in which we've performed this, we can see we have 3 pieces. And if I choose any measurement and look at the statistics, I will see a trend chart, for example, on the circle diameter that shows us the measurements. So this allows us to have a universal project that combines all the results from all our pieces. This is great. Now, here's a question, and we're going to do it with the poll again. Knowing that we have 3 pieces in that project, which one would you have to select to be able to perform a new piece inspection on a portable arm? Now, you can go ahead and try to guess if it's piece 1, piece 2, or piece 3. We saw this morning that the current piece actually drives how you're going to inspect the new piece you're asking to make. But the thing is, we only have 3 pieces in that project. And maybe some of you are confused. You don't remember exactly which order I did what and what CMM I used, when did I use the arm. Let's take a look at the results. You guys are good. I have a majority of people that said piece number 2. But we can say that it's still a bit confusing. Well, everything we have told you this morning regarding piece template is to actually solve this problem. Let me show you. So one of the biggest problems so far with our projects, even though they were universal projects because they could be easily brought to any device, first of all, you don't want to have to make those changes as you're on the shop floor. Even though it wasn't very complex, you could create issues if you're not really into what you need to do. So you want to be careful. And at the same time, in terms of efficiency, you want to plan ahead. You know which device type you own, so why not make the project complete even before you release it so it's being used on the shop floor? So this is truly a universal project. Now, how can you do this? Now, piece number 3 is the one I actually made on the horizontal arm CNC CMM. So instead of creating a new piece right away, once a piece is completed and you know this is the piece template that you want to use, you can create a piece template out of a certain piece inspection. And that is whether it has been done in simulation mode or if it was inspected for real. So in this case, I'm going to say this is my horizontal CMM. And now whenever you do this, you're going to see that in the piece list, you not only see the pieces, but also the piece templates. Let me continue. I will jump to piece 1, which was my, which was the first one I built the project with, and that one was used on a bridge type CMM. And then finally, piece number 2, which was the one that was made on our portable arm. And that means now, whenever you choose a piece and you decide to go with a new piece inspection, like in this case, if I want to make a new project or make a new piece inspection using a portable arm, instead of using the current piece to perform the inspection, I'm going to go with a piece template, and I can choose between the templates I created. I forgot to save one, I'm sorry. But the point is here, if I go with portable arm, then when I launch Play Inspection, you're going to recognize that the sequence tells me that I need to connect to my probing device, and this is where I would flip the switch and start making the inspection. So this is the proof that now you have a project that is universal, because you have planned ahead of time which templates are needed for all your measurement devices. Very good. So let me just conclude briefly this workshop. So just to summarize, the Universal Cube platform increases your workforce mobility simply because anyone can measure anywhere with any device that you have in your company. It also allows you to create a very flexible metrology process, which makes problem solving for your metrology team or your engineering team much easier. And of course, it facilitates broader collaboration between teams, as basically a universal project can be prepared in advance for all the devices that are in your organization, and they could be shared in the different facilities where you would conduct those inspections. So thank you for attending this workshop. Now I'll leave the stage to my friend Todd here.